there's another term I'd never heard before, is the compound nucleus topic. If you could dig into that a little bit, because that one's pretty new to me. I know we've discussed the oscilloscope signals that we're getting, as well as the signals that are coming through on the pulse counter for our X-ray detectors.
Yes.
Now, that same signal type doesn't happen with our other detectors when we're detecting things, so it's special with the X-ray.
Right. Because of the neutron moderator and the Delrin moderator, our gamma ray detector and our neutron helium-3 detector, though it does detect gamma and it does detect neutrons at like thermal levels that are low, we don't see the negative compound nucleus signal. And just for the audience, a compound nucleus event is when, and it's actually Niels Bohr, he came up with it, is that when you have an atom that has a nucleus, and then you have another atom that has a nucleus, and when they come together, and then they go like this, and they cross over, and they go into a fusion type of event, that is a nuclear cross-section. And what happens is when they get excited when they first fuse, but then as they're trying to renormalize back to stability, they're vibrating. It's almost like an echo. It's like, and then it kind of goes below the stable state at what it was before. So compound nucleus goes stable state, excited fusion state, and then as it's fusing, it's ringing like a bell, ding, and then it goes below stable state, and then rings out and then tries to go back to normal. And we see that same signature in our X-rays. And that's, again, like we talk about nuclear cross-section. Like if you have a nuclear bomb go off, you're going to feel it from far away too, right? And all the X-rays are feeling this echo of a compound nucleus far away, just like gravity. Because of mass is pulling in and it's causing a fusion event to form a planet or a moon or whatever. It's a negative force from a nuclear reaction. Kind of wild.
It's fascinating stuff. It's definitely outside of the normal awareness here.
And so you can see on the oscilloscope here we have a bifouler transformer that has an iron core, just like a planet. A planet has an iron core just like this. And then on the inside of the core is you have current flow, right? Like you have magma and you have, volcanic stuff that are trying to weep out of the crust. And so this transformer is acting just like a little planet because the current is flowing through the wires and they're jostling back and forth. Like magma in a planet is not stable. It's not just a flowing thing. It's a what did you call it in the episode?
Intermittent.
Turbulent. It's turbulent flow.
Yeah.
So it's ringing.
Because the core and crust are spinning at different directions, so they're kind of stirring it up between those layers as it's going and making this mixing of material. And when you move around electrons, you get magnetic fields.
You get a magnetic force. And that's the beautiful thing too, is that like if I pull out the magnetic core, if I can do this without making a mess, if I pull out the magnetic core, you can see the signal changes on the oscilloscope. And if I put the magnetic core or the magnetite, essentially crystal that's inside a planet, you put it back in, you get the resonance again, and you get more of the negative pulsing action, which is more of the gravity.
Yeah.
Which is pretty cool.
It is.
It all makes sense, doesn't it?
Kind of. Little bit by little bit.
Well, and here's the thing about a planet. It has a north and a south pole. This has a north and south pole too, this little transformer right here.
Which is changing.
It's
back
alternating.
And forth as it's alternating. Right.
So it's almost like there's a DC signal and then also an AC signal in here, which is really interesting, but like...
Yeah, it's kind of a stacking of signals. This is another one of those places where like your ham radio operator is actually set up very well to understand a lot of these dynamics that we're dealing with.